This video is continuing sets and notation. We're going to be finding unions and intersections. So remember that unions contain all elements in two or more sets. Intersections contain the elements that are shared between one or more sets. This is when you're dealing with an overlap. So this example, we have three sets. A is 1, 2, 3, 4, 5. Set B is 2, 4, 6, 8, 10. And set C is 5, 6, 7, 8. We're going to draw Venn diagrams to represent. We're going to talk about the A intersect B and A union B. So with this Venn diagrams, we're still only dealing with A and B, so we don't have to even worry about C. We can completely ignore C. We have to ask ourselves if A and B intersect completely or partially. So there's three ways. They can intersect completely, partially, or not at all. So if we look at A and B, we look to see if there's anything that overlaps at all. We can see that the 2's overlap, the 4's overlap. So that means that they will intersect partially. That means that we can draw out a Venn diagram that has our two circles that will overlap partially. If they didn't overlap at all, the two circles would be separated completely. If there was a subset, if one of the sets was completely inside the other set, one of our circles would be completely inside the other. So we can say that this is set A and this is set B. Now the overlap, this part right here, is where they intersect. So this is the actual, this section is the A intersect B. So what we want to do is figure out all of the values that are in the intersection of B. Of A and B. So intersection of A and B would be, is 1 inside of B? No. Is 2? Yes. Is 3? No. Is 4? Yes. Is 5? No. And since that's the end of set A, we can actually close our bracket because it doesn't matter what's in set B any longer because nothing else from set A is in set B. So the intersection is the 2 and the 4. So in this middle little oval, we would put the numbers 2 and 4. Now the rest of this Venn diagram is talking about what is left of A. If I were to separate these two circles, the numbers 2 and 4 would actually go with both circles. So I need to look to see what numbers are left over from set A that I don't already have written. So from set A, I don't have the number 1 written. I have the 2 already here. I don't have the number 3. I have the 4, but I don't have the number 5. So this is everything that's included in only A. So only A has the 1, 3, and 5 of these two sets. 1, 3, and 5 are only in set A. But we have 1, 2, 3, 4, and 5 inside of set A. There's a big difference in understanding the wording of this. This is only in A. This is all of A, because that entire circle includes A. Then we also need to say what is only in B. So if we look back at set B, we have to look at this overlap again. So with set B, I've already written the 2. We've already written the 4. We have not written the 6, the 8, or the 10. The 6, 8, and 10 are the numbers that are only in set B, but all 5 of these numbers are a part of set B. So the question is, what is the intersection? Which part of this is the intersection? Intersection is where they overlap. So the two numbers that they overlap are the 2 and 4. So this part is actually our answer. The intersection, the overlap of them. We want that part for the intersection. Now since for example B, we're still dealing with these same sets, I can actually make my Venn diagram the exact same way. So I'm just going to recopy this Venn diagram. I have a circle, a second circle slightly overlapping. This first circle is set A, the second circle is set B, and the middle is the A intersect B. That will always be the intersection no matter what. So I still have the numbers 2 and 4 in the middle. I have 1, 3, and 5 are the numbers that are only in set A. And we have the numbers 6, 8, and 10 are the 3 numbers that are only in set B. So the question is asking, what is the union of A or B? So A union B. I need to write out all of the numbers that are in set A. Then I need to write out all the numbers that are in set B. So the answer for that, the union, we start out with set A. They're in numerical order, so that helps us. So we can write out all of these numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we have to go over to set B. 2 is the first number. We've already written that one. 4 is the second number. We've already written that one. Then we have 6, 8, and 10. Those numbers have not been written, so we write out the numbers 6, 8, and 10. 6, 8, and 10. And then we can close our set. This is actually the union. So what that means is that when I highlight my answer on here, I need to make sure I highlight the numbers 1, 2, 3, 4, 5, 6, 8, and 10. The 1 is in set A, is only in set A, the 3 and the 5. So those 3 numbers are here. The 2 and the 4 in the middle, and the 6, 8, 10 are over here. So the union is actually the entire Venn diagram. Not the outside of it, but the 2 circles themselves. But that also includes the overlap. So all of this is the union, because all of this is set A or set B together. So that's our union. So the Venn diagram is always going to be written the same way. We're going to have set A, set B, and then the overlap. Now the outside of it would be any of the numbers that were not written. So we could say that the rest of this would be the numbers from set C, because this is all of the sets. So we have the number 5 already in one of our circles. We have the number 6, but we do not have the number 7. So and we do have the 8 in here. So technically 7 could be written on the outside. So this could also include the number 7 right here. Because these are the numbers that are remaining from these 3 sets up here, but they are not a part of A and B. This next example is using the Venn diagram to determine how many students are in each. There are 26 students at Lake Norman High School who take either calculus or physics or both. This is just an example. I'm using 26 because that's the letters of the alphabet. So we have a total of 26 students. That means that we can only have 26 letters written out. Each student is represented by a letter of the alphabet below. Draw a Venn diagram of the situation. So we have 2 things. We have 2 sets. We have to determine if they overlap completely, overlap partially, or not at all. So we look at A, it's not in here. D is. So we already know it's going to overlap partially. We know that it will not overlap completely, and we know that it will not overlap, because there is overlap, but all of calculus is not in all of physics. So we know that it will only overlap partially. So I'm going to draw 2 circles. We have 2 sets. We're going to name the first one. It's going to be calculus. You always need to name them. The second one's going to be physics. And in the middle, it's both. See, we have calculus, physics, or both. Now all we do is find what letters or what people will overlap. That's the easiest way to do that, is to find the overlap first. So if we go through calculus, I'm going to focus on calculus. A is not in physics. D is. So I'm going to highlight the D for both of those. The F is in physics as well. So I'm going to highlight F. The I is in physics. The J is in physics. The K is in physics. The L is in physics. The M is not. P is not. R is not. T is not. V is not. X is not. Y is not. And Z is not. So these are all of the overlaps. So what that means is you take all of these letters, the D, F, I, J, K, L, and you write them in the both, because it's highlighted in both of them. You do not write those letters in the individual ones. So we write out D, F, I, J, K, L. These are the letters that are in both. So now for calculus, we write out the remaining letters that are not highlighted, because these are the letters that are only taking calculus. So we have A, M, P, R, T, V, X, Y, and Z. Those are the letters that are only in calculus. So then over in physics, we do the same thing by finding the letters that are not highlighted in physics. So we have B, C, E, G, H, N, O, Q, S, U, and W. These are the letters that are only in physics. But again, if you were to separate the two circles, you would see that these 6 letters would actually be in both of the circles. So that would have to split apart and actually take it into both of the circles. That's why they are in both of them. So what we could have done is written out all of the calculus letters, all of them, all of the physics letters, and then just taken the ones that overlap, crossed them out of the individual circles, and put them in the middle. That's one way of doing it. You're basically subtracting the letters from them.